diagram. So I'll share my screen. So basically LSTM is a special version of RNN to solve the short-term memory problem. So LSTM is long short-term memory. So if we read this sentence, say take an example of autocomplete. So we are saying today, so as to pay my MTech fee, I need to take a loan. Here the model is able to predict need to based on this particular word today. However, if the word was sentence was like starting with say last year, then autocomplete will suggest I had to take a loan. So this is in very simple words. This is what LSTM is made for, taking into account the long-term memory. So going into the architecture of LSTM, let us consider the RNN. So in the recurrent neural network, we feed each word one by one. So today and then so as to, if we consider this particular first sentence. So if I roll this out, this is only one network. But if I roll this out in time t, then t plus 1 and so on, so it will be like this. So first one will be today, then so and as, and so on. And here comes the need, for example. I've taken this example from one of the YouTube videos, and uh, so this is what we are unrolling in terms of time at different time sense. Let us discuss more about the memory cell now. So here we are representing the short-term memory in terms of H and the long-term memory in terms of C. Uh, Now this was a notation. So what happens? The short-term memory. Uh, Before that, I mean the decision versus need to versus had to was taken based on the what happened in the beginning. So what happened? We can say could be this is a part of the long-term memory. Uh, so. Uh, the traditional RNN have a short term memory of few words. They will focus on maybe say initial the words coming together, so as etc. When it goes till this particular fee, it has already forgotten about the word today. So with LSTM we can solve this problem. And so we discussed about this is the silent state, this is the hidden state, this is the input xt coming. So in the normal RNN, what happens? We have this particular we have this um, uh, xt into weighted sum plus ht, and then we take tan h to get the new hidden state. Right. Let us say take one more example here. So this is the exact example I'm reusing it. So Dhaval eats samosa almost every day. It shouldn't be blah blah. That is hard. That's favorite cuisine is Indian. So Indian is being guessed based on the word samosa, right? And so again, however, if we make it more complex, so we can say that in this long-term memory, samosa was being stored. Another example is when we add one more sentence. His brother Bhavin, however, is a lover of pasta and cheese. That means Bhavin's favorite cuisine is Italian. So as soon as the model encounters the word pasta, right, it throws this word samosa out of memory, and then it also stores the word cheese as well in this second diagram. So removing the word samosa from long-term memory is storing the word pasta and also storing the word cheese, not discarding pasta. So this all is done during the training phase. So now going further deep, so we have some of it is done by using some of the gates. I'll just try to explain those. So there are forget gates like this, and there are in addition to that forget gate. So we had samosa in memory, so we had to forget samosa as soon as the model encountered word pasta. Then we have input gates. So how do we add the new keyword, which is pasta and the cheese, and then we have the output gate. So these all can be, the simple explanation to, explain these words is, um, so we can say, let us take this example. Let us take this example. So here what we are doing, this is the long term memory, right? So we'll say, 10h of this long term memory, and then multiply this with 10h of the, sorry, I just mixed that up. So uh, so hidden state, this is the hidden state multiplied by x, and we take the weighted sum of hidden state and xt, right? So
Correct?
this xt and hidden state, we take weighted sum and apply sigmoid on that.
Correct.
And then this is the input gate. We multiply this particular input, which is coming as sigmoid of the weighted sum of hidden state and xt. Uh, Hidden state and xt, sigmoid of this is coming here. Multiply that with 10h of the long term. So this is 10h of the long term, and we get this particular. Um, we get this particular next current hidden state. So this is how the calculations work. I didn't copy the exact formula here, but it is something like this.
Mm-hmm.
And so LSTM can be used to solve that short-term memory problem in sentiment analysis, or speech recognition, or language modeling, or say video analysis.
Okay. Why in particular you're talking about sentiment analysis or text here?
Uh, Text, because we try to relate the what we said previously, which was maybe at the beginning of the sentence, and
Hmm.
which can be stored in the some keyword which can be stored in the long term and can be used at the right point in time while traversing the sentence. So I will go to the same example. So, for example, this particular word samosa, and uh, we need to know this particular keyword to predict about the, or
Correct.
uh, suggest about the cuisine name, which is Indian. However, we need to also forget this particular keyword and store this
Hmm.
pasta keys in memory to predict about the word cuisine Italian. So this, collecting the data in the long term, forgetting it and adding it, all these are done through gates, and this is the main, I will say, the use of LSTM. We can, when the sentiment analysis, we said something, and using the normal model of RNN, which focuses only on the previous one or two words, like say his or favorite, whenever we are at cuisine. So
Hmm.
understanding that particular context is not possible using RNN, for example.
Hmm. So, what is the difference between these gates? Which gate do you think is important when we are dealing with text data? Or
So
probably let's say when you're building a sentiment analysis model or a text classifier, which gate do you think will add a lot of value to us? And which gate is just there for the namesake?
so I feel, both forget gate and input gate are also, forget and output are both are important. And I'm not able to differentiate, which one is better in terms of effect, in terms of uses in this context. But
Okay.
forget gate is
Let
equally important as the input gate. That is what I believe.
okay,
For
let me ask you in this way. So suppose let's say I'll customize my own LSTM layer and I'll remove the forget gate from it.
yeah,
Okay. So LSTM architecture is as is. I'm just taking off the forget gate from it. Now what? would change in the output?
One change we will need to say both the words are there. For example, uh, the words like cheese, pasta, and samosa. So which one came earlier? We can relate to that, and we can assign the weightage based on the timestamp. So the word coming nearer could be of higher weightage, and so in order to answer your question, I think forget gate is something which we can do away with.
Mm, okay. Anyone else? What are your thoughts on that?
If we remove the forget gate, it will be difficult to retain the previous cell state. So
Why and how?
I think forget gate is important because we are. It helps us to discard things which are not contextually important for the processing.
Okay.
I think I will agree with what Kadir said. So,
Mm-hmm.
because we have the information about the immediate things at hand, but if we don't remove the forget gate, so we won't know what is the relevant information from the prior steps or prior timestamps. Input gate
Okay.
will be required because anyhow we need to have uh, the keywords being getting continuously added to the long term memory.
Okay. So still, I think Soumya, wonderful job. Hats off in getting into the details of LSTM. But still, it's not clear to any one of you on how the gates actually work and are interconnected. Okay, so now I'll give you 5 minutes. But the reason I was asking all of this question was I was getting into bidirectional LSTM, right? I'll give you all maybe 10 minutes. Okay, go through LSTM architecture again from your deep learning module, and then for first 5 minutes, and then for next 5 minutes, read about LSTM, bidirectional LSTM. Okay, and then let's have a presentation from any one of you again in next 10 minutes. Very important before we proceed further, because we're going to get into BERT, sentence BERT, Elmo, and a lot of such algorithms, right? GPT transformers. So, okay. So your time starts now. Are we all ready? Yes, no, need more time?
Need some more time, sir.
Sorry?
No, I was telling we need some more time.
Okay. Another 10 minutes?
Yeah.
Okay, fantastic. So, I mean, please remember, without understanding LSTM, we cannot move further. Otherwise, none of the further concepts will make sense. Okay. So, all right. Another 10 minutes starts from now. All right. So who wants to take the lead? Yes.
Sir, I was able to understand the uh, theoretical concept, but couldn't figure out the gates, the specific question you asked.
No, that's okay. But you were able to understand bidirectional LSTM?
Yes.
Okay. Please go ahead.
So,
No, 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 not Soumya this time. Anyone else?
Akshay, I'll try.
Awesome. Go ahead.
Are you able to see my screen?
Yes.
Yeah. So this is the architecture of bidirectional LSTM. So the difference is that LSTM can be used in one direction, say from front to back or from back to front. So bidirectional LSTM employs a combination of this. So there are two layers. One is the backward layer and forward layer. So the input is fed from both ends. It is fed to the forward layer as well as the backward layer, and the output, the input is for uh, each input is fed to backward layer as well as the forward layer, and the output of these is fed to a sigmoid function to give the output which is expected. So this way all the LSTMs involved in the forward and backward layers uh, provide a provide an output for each input.
Mm, okay. Soumya, you want to add anything on top of that?
um, uh, we pretty much covered just one small thing. Uh, so sometimes there are cases when we, to understand the word in the context, we not only need the previous words but also the words coming after. For example, if I say John loves apple, it keeps him healthy, or John loves apple because the company produces great products. So John loves apple is same in both the sentences, but based on some of the words coming after that, we are able to decide the context. Hence the use of the backward bidirection LSTM, which adds a add one more LSTM layer, which reverses the direction of information flow.
Fantastic. Okay. So now on the same topic, since I asked this question last time as well, encoder decoder. Now, can you explain encoder decoder on the same topic? How encoder decoder works, or auto? Please don't tell me that you forgot autoencoders or encoder decoder architecture. Santosh, you want to explain autoencoders or encoder decoder architecture? This is disappointing. No one knows how autoencoders or decoders work?
I mean, I can go if nobody's. So I'll try to simplify it and give it.
Mhm.
So, in a typical neural net or any neural net problem, so I'll try
Mhm.
to give term and correct me if I'm wrong. So encoder is or decoder will probably try and pick up an example so it's easy to understand. So what in a high level what they do is when an unstructured data or an image is given to an encoder, it tries to, we can say, draw it, and the decoder guesses the drawing and memorizes it. And what happens in this entire game or so-called model is the encoder is called root 1 and decoder is called root 2, and the
Mhm.
encoder picks up the image from the fed input variables and it tries to draw, and the drawing is being guessed by the decoder to memorize it, and then that's how it tries to memorize the matrix of the drawing as well. That's in a nutshell what encoder decoder does.
Exactly. Exactly. This is awesome explanation. I loved it. So anything which is explained in a layman, you know, that's something great to hear. So now everybody clear with encoder decoder? Yes.
Yes.
Sir, I put one URL
Correct.
in chat box, sir.
Mm-hmm.
In this, just one picture.
Mm.
My heart, it is input is giving. You while speech, and just we are giving. Heart is not enlarged like that there.
Mm-hmm.
And in this explanation of this algorithm, it is written that improving the context available to the algorithm,
Correct.
like that it is written, sir.
Correct.
So
Correct.
this model, bidirectional model, is fit for this live speech context development, like that it can be used for chatbots, and that means bidirectional. We are talking with the system and system is responding, that can be implemented like that, I feel.
Mm. Correct. Yes.
that that I want to tell.
Yeah, absolutely. Good. So now let me share my screen. You able to see my screen?
Yes.
Okay, now I have these two texts with me. Okay, and I want to capture the context, especially for Apple. Okay, now my question is, will simple neural network be able to capture? Do we need RNN? Do we need LSTM, or do we need bidirectional LSTM?
By LSTM will be more preferable over
Okay,
others.
can you please explain why?
So, uh, in this XYZ CEO of Apple, that can be uh, resolved using LSTM as well. But I like Apple. I'm using. I mean, we can also use by LSTM, but could be an overkill for such a simple sentence.
Mm,
Whereas the first one, I like Apple. I'm
mm,
using it since last 5 years.
mm,
So this is still ambiguous. Using means eating or using as a product.
mm.
So here still I'm not sure whether by LSTM, even by LSTM will be able to give the desired results.
Okay,
Okay.
no, wait. No, sorry.
Isn't LSTM part of? I mean, RNN's sibling is LSTM, right?
Correct. So RNN is kind of a neural network. LSTM is kind of an RNN network. Bidirectional LSTM is kind of an LSTM network.
Correct. Yeah.
Yes.
Now with this, the by LSTM will be best suited for the first sentence
Mm-hmm.
because I like Apple. After that, we also can feedback the word Mac, so we can get the context that the context is the product.
Correct. Now you know word to vec. We discussed on day one how it works.
Yes.
Correct. So let me go back to that. Where is my word to vec? This is my word to vec. Right? Didn't we try doing the same thing? Didn't we try extracting the same context in a different way using the same neural network architecture? We didn't even look at LSTMs. We didn't even look at bidirectional LSTMs or encoders for that matter.
Yes.
Correct. Now, why do you think there is a need of LSTM then? When word to vec can handle this as well. Okay, now maybe for everybody else to recap, if you're not able to recollect how word to vec works. So it has two kind of model. One is bag of words, CBOW, sorry, continuous bag of words, and then the skip gram, right? So now what it does is every time it takes the surrounding word as an input and tries to predict the middle word or whatever word of interest, right? Now for here, if you want to predict Mac, if your target is Mac, n-gram before this and n-gram after this will go as an input. If you want to predict sense, similarly, n-grams before that and after that will be collected. Now, skip gram is just vice versa of that, wherein you will use a word to predict the context. In one of these, you are using a context to predict a word. In the other one, you are using a word to predict the context. Context as in words surrounding it. Now, even this can solve this problem. Then why do you think people went beyond word to vec? Word to vec, glow, fast text are same. They work based on the shallow neural network. Just that one is from Google, one is from I think Facebook, and the other is from Microsoft. It is purely based on the neural network architecture, shallow neural network. Now, when this was there, probably I think in 2015, I think when this got started, why do you think there was a need for transformers? Yes. Transformers are easy. It's you already know it.
I mean, we essentially in any uh, text you have to weigh, and to weigh the words you need a function, and that's what transformer and encoder will do. It will weigh the words with the sigma function, and using the tannage it will discard which is not required. That's what
Yes.
sim can do and what we cannot do.
Correct. I loved it. It's simple and straightforward, right? We need not to get into the technical details at all. If you really understand how those gates work, and if you really understand what does bidirectional LSTM mean and what encoder or decoder does, our job is done. Now, Sandeep answered first part of it, but there is second part of it as well. Let me reiterate both parts again. Part one, which predominantly focuses on accuracy. Part two, which Sandeep just mentioned. Part two predominantly focuses on efficiency. Your accuracy is improved by your TANH or probably the bidirectional LSTM network. But then efficiency is still at a toss. That's wherein you need to pick. So it's like your, I mean, if you know feature selection in your machine learning, how important it is. Similarly, not all surrounding words are important to capture the context. Do you agree with me?
Yes.
Correct. So that's wherein bidirectional LSTM in combination with autoencoders plus attention mechanism will give you transformers. Now you must be wondering how this, first of all, I know this architecture. On top of this, BiLSTM architecture is pretty straightforward. On top of it, maybe let's say I'll add autoencoders. Then on top of attention mechanism, how do I even imagine this architecture? Shall we get into the technical details of this? Are we good on the why part? Now, once you understand this, your rest of the journey becomes easy. BERT, GPT, sentence BERT, and then I think we have few more. Elmo, and then we have, I think in GPTs also we have versions, GPT 1, 2, 3. And yeah, I think few more. I forgot the name, but yeah, we have few more, which are dependent on the concepts of this.
Akshay, sorry to interrupt. One question, or rather to understand. So, word to vector won't have the context definition with itself.
It does capture context.
So, for example, we use the corpus. We used the word to vec on a corpus earlier.
Hmm.
There was no label that time in the
Correct.
initial class, and we got an output of vector representation.
Correct.
Uh, so without any context, that could be a very primitive use case. I think that was
No,
the
no,
case.
no. Soumya, I think you got it wrong. So you don't need a label data target for any kind of embeddings.
Yeah, I mean, sorry, the context was not there. I can use the word, say, uh, cell to have the cell phone or the prison cell or etc. or
Okay.
anything related to membrane cell.
Okay.
Use the corpus, create a corpus of. We can train on that corpus. Now, there is a context in that word to vector.
Correct. Correct. Yes.
Whereas in case of BiLSTM, at least, and correct me, we have some little bit of context. If not, that great.
No. I didn't get you. So what you're saying is, okay, you have, let's say, 10 sentences with you, which talks about cell.
Yeah.
It could be biological cell or your telephone or whatever, right?
Yeah.
Now
Yeah.
on top of that, you're training your word to vec.
Right.
What's next? So you're getting that will it capture context or not? Is that your question or
Yes. Is my confusion is that.
yes? Context is definitely captured.
Okay.
There is no doubt. Even here the context is captured. Even here the context is captured. But the problem with word to vec is, again, like you say, let's say I have a sentence with 20 words. Imagine the permutation and combinations it requires of n grams. Correct?
Right.
And not every time you loop into or do n cross n. You maybe
Right.
do 2 or 3 grams. By default, it has some hyperparameters. In that case, this becomes difficult to be captured. This becomes difficult to be captured because Apple is way far away from Mac.
Right. Right.
Or maybe I'll add few more words, right? So now it becomes difficult. I'm not saying it won't capture, but like I said, the part two, this goes on a toss. Now, the reason for Google or Microsoft or Facebook to crack all of these SOTAs are main reason is efficiency. Word2Vec does give us wonderful results. We'll do that. We'll do comparison, right? While we get onto the hands-on in maybe few hours. So the point here is when you're running it on trillions of data, imagine the state. Fast text is still faster compared to Word2Vec and Glow. And all of these are same shallow neural network. Just that fastest optimized their n-grams.
Okay.
Okay. Now coming to your question on bidirectional LSTM. Now maybe I'll answer that question once attention mechanism also done. So you understand. Oh, but then it's clear now, right? So I still see it's a gray area for all of you, except Sandeep, on how these work in combination to get us these.
Yes, and especially for a sentence like he was sentenced to prison cell by the judge using the message on the cell phone, using evidence of his blood cell samples, for example. So your cell is being used in different three notations,
Correct.
and to vector, whether it will be able to capture all those.
Yes, it will be.
Okay,
It will be.
that answers.
Yeah.
Thanks.
Okay. Now we'll try it out, right? We'll see all of it. And now maybe if you're that curious, I'll probably show you right away. I think yes. So this search engine we will build it in some time. But since you all are talking about it, let me quickly just show you. So I have few sentences with me. Absence of sanity, lack of sinness, a man is eating food, the girl is carrying a baby, the man is riding a horse, the woman is playing violin and whatnot. Okay. Now I do TF-IDF vectorizer. Simple. So I imported the libraries. I have few sentences with me. You can call it as corpus or whatever. I use TF-IDF vectorizer. Why I use TF-IDF vectorizer? What is the objective of me using this?
Convert to features.
Correct. I have converted to features. Now, query. This is my search engine done. Now I'm passing a query, cricket. So when I search for cricket from these sentences, which all should come on top? So I pass my query as cricket. I'm just vectorizing it. And then I'm doing a cosine similarity between the query and the these sentences, right? And I'm just printing top 3 results. So these are the cosine similarity values, and now I want to print top 3. Cricket is my favorite game. Cricket is my favorite game. So I got cricket as a output. And then a cheetah is running behind its prey. I'm getting this. And a monkey is playing drums. Why I'm getting this? It's just randomly choosing other two because the rest all of them are 0. Correct? Are you clear?
Yes.
Clear? So I'm searching for a cricket from that corpus and I'm just getting one match there, which is this sentence. Cricket is my favorite game. Clear? Now, let me move on to, I'm searching for pregnant. I do the same. Then I do the cosine similarity. It's not matching with none of them. So again, it gives randomly 3 sentences. It's not matching with any of them. Clear? Now here I'm trying to use sentence transformers. Instead of TF-IDF vectorizer, all of these are pre-trained models. We all are lucky to be in this age wherein we don't have to worry about building these models. For us to be, I'm not saying we cannot build it. We can build this model, but do you have the data? Other than Google, Facebook, Microsoft, nobody has that amount of unstructured data, text data. So they used all of that data to train this model and put it as a package. So I install sentence transformer and then import it, and then I just call their base transformer. And now I use the same sentence. Now, after I do the BERT, so I do BERT vectorizer now. Model.encode sentences. I do sentence embedding. So I do model.encode from BERT. Okay, this time it's, sorry, sentence transformer. Now that is done. I'm here again searching for pregnant woman. If I would have used TF-IDF, I would have got this on top. Correct? Do you agree with me? The girl is carrying a baby. Is there a word like woman or pregnant here? Then how could it come on top? You're getting my point?
Yeah.
Right? And then cricket. Cricket is my favorite game. Okay, fine, you got it. Hit, wicket, and boundary. Is there a word cricket over there?
No.
Right? So this is how NLP has evolved in last 3 to 4 years. People have struggled to improve their search engine, but this Fang changed it in a day. But then even still, some companies are failing to catch up with their search engines. Right? And then, I mean, this is another example where instead of we choosing some small amount of sentences, you give a news headline. I mean, this is a data set, I'll share it with you. And then try to search for any news and it will give you those news, whatever you want to read. And your search engine is just 3 to 4 lines of code, semantic search engine. So this is the beauty of word embeddings. Okay, so now, okay, at least now you are motivated to learn about LSTM and details about how it actually works. Anyways, for you to implement this, you need not to know. But when the time comes, okay, let's say you are into a particular project or a company where you want to build a search engine. Okay, let me just quickly check if Graphers has fixed it. Oh, it has been changed to Blinkit, right? It's no more. I think Okay. So what was that?
Rice flour.
Rice powder. Yeah, they fixed it. Yes. Before we never used to get this rice flour on top. We used to get detergent powders on top. I've shown you this when we met few months back. Now detergent powder, it's coming over here. That's still okay, but if I'm getting my results on the first two, three options, I'm good. I'm happy. Right now, it is able to relate. Oh, flour and powder are same. It has been contextualized. I'm telling you, in last 3 years, I have built search engines for at least 120 e-commerce platform. I mean, I as in I and my team, at least 120. So that's the opportunity we had when all of this got released. Initially, we did try with word to vec and all of it, right? But two things. One is efficiency was a hit, right? It used to take a lot of time sometimes. But for you, latency is of utmost important when you're running a search. So keeping all of this that in mind, a lot of companies started bringing in their own version of transformers. Okay. So with this note, I'll give you some introduction on what is that we're gonna learn today. So we are yet to talk about our assignment.
Akshay, can I ask some question here?
Yes, please.
This search engine, it is hosted on the cloud, right? What you mentioned
Correct.
for the sequence.
Correct.
So, how will it be? What it needs to be put it on an edge device?
Sorry, come again.
How can we scale it down to be placed it on an edge device?
Okay. And what is your business case here? I mean, why you want to place there? You want to put it for any app or what is it?
Yeah, it is kind of an app for automotive.
Okay. And now see again, right? So we have maybe let's say 4 options.
Mm-hmm.
Option number one. Usually, I mean, maybe 5 years back, we used to go with VMs on-prem. Correct?
Yeah.
Right? And then people started moving to cloud.
Mm-hmm.
Okay. Now, how does it make as a difference if you want to have it as on the devices?
Mm-hmm.
Now, my question to you is,
Mm-hmm.
I mean, explain me your business case. I'll tell you what solution fits in for your app.
Mm-hmm.
First, I want to understand why it doesn't fit here. Why it doesn't fit here? Yeah.
Why doesn't it fit here is because I want to build speech recognition systems for Indian languages
Okay.
in automotive within an automotive environment. Yeah.
Mm-hmm.
So, for example, if you want to do body control within the car, or very simple automotive use cases like that. Yeah, so where it's really not needed, so we can get it. So for that, so we need to do, that's the business use case I can do.
Okay.
Hello.
In that case, right? I think see one thing for sure which would be very important aspect is how do you ensure you're using the right library or set of things to run it on edge?
Hmm.
Correct? So
Yeah.
I think I do remember while I did not really do it on Edge, but I think there is some package around it. Uh, Runbird, I think it's, if I'm not wrong, which does this for us. One second, let me. Yes,
Okay. Rune Baruta. Hmm.
yes. Oh, sorry, Runebird. Yeah. So
Hmm.
to embedded devices to unlock language. I think this is exactly what you're trying to do. Mobile BERT. There's mobile BERT as well. RuneBERT. So for specific kind of integrations, you
Hmm.
use this, right? So you can have this as a base, and on top of this, you can use any of the transformers. So that flexibility we
Oh.
have. Okay.
Okay.
But
Okay.
I'm not sure if this was your question, but from an architecture stand, right? How this fits in into Edge, I'm not sure.
Yeah.
Wait,
Okay.
wait, wait. No, no, no. I think I got it. Maybe this is your question. Why and how is your question, if I'm not wrong.
Yeah. Correct. Correct. Yeah.
It doesn't matter if it's really in NLP, right? It could be any of the algorithms,
True. True.
correct?
Yeah.
So maybe I have not done this in past, but I can help you answer your question. Just a second.
Hmm.
So what is your edge device?
My edge device will be an ARM 11 core with Android.
Okay. So that's what, right? I mean, like I said, so even as far as I see, it's no difference other than this. This is the only
Yeah.
problem what you face between these,
Hmm.
right? But otherwise, the architecture wise should pretty much remain the same. So, like I said, that's the
Correct.
reason you have these lightweight libraries, like I showed,
Hmm. Hmm. Hmm.
right?
Okay. Yeah.
See, there you have like maybe I think there is no rocket science here. So, yeah, so here you have two options here.
Hmm.
Okay, one is use lightweight if there is a need of training. Now,
Hmm.
what happens is, let's say if you're working on search engine for search engine for some pharma company.
Hmm.
Okay, this happened to me. I'm just giving you the real world example. Right? You are trying to
Hmm.
build a search engine for a pharma company. Now, do you think, I mean, like I showed you, right? I just use what? I just used sentence bird here as is. Okay. I used
Hmm.
as it is. I did not train it. If you realize that, I did not train any model here. I used a
Hmm.
pre-trained model and just encoded this. Correct?
Hmm.
Yes. So I used a
Yeah.
pre-trained model. Now, do you really think if I use the same bird, it will give a good result on for this search engine for this pharma corpus? Your answer is no.
Yes.
Or maybe you don't
Okay.
know. Or your answer is
I
yes.
don't.
Why?
Yeah.
I'll tell you why you got confused. So whenever you are using such libraries,
Hmm.
let's go to BERT. BERT,
Hmm.
not blog kit. So it will tell you all the details or go to the research paper. Uh, and it talks about
Hmm.
what is the corpus they have used.
Yeah.
What is the corpus on which these models are trained on?
Models are built. Yeah. Correct.
Correct. Now, if it's from
Hmm.
Google, it's obvious that, oh, how do they get so much of medical data with them?
Hmm.
Train on. So that my accuracy of search on the medical data is high. No,
Hmm.
it will never be the case. Right? So it's
Hmm.
important. So before you use any of these libraries, it's
Hmm.
important you to know on what they are trained on.
Correct. Yeah.
Correct? If Google, if
Yes.
it's
Yes.
Google, they you always go with the news. Trust me,
Yes.
news data.
Yeah.
If it's Facebook, it
Yeah.
always goes with your posts, right? So
Yeah.
that's how they are trained on. Now, for me, this was a
Hmm.
task. So what I used this as a base knowledge,
Hmm.
right? For me, because I need some context, right? I'm using this as a
Yes. Yes.
base knowledge,
Correct.
and then I'm doing transfer learning on top of it using
Hmm.
the same medical corpus,
Hmm.
right? So
Yeah.
that's how we usually do. Now, if at all you want to build this search engine for a pharma company or an edge device,
Hmm.
this option is ruled out for me.
Hmm.
It cannot support you training on such a huge data and that too such a complex algorithm,
Hmm.
right? You fail miserably.
Yeah.
Now you have
Yeah.
two options. Again, like I said,
Hmm.
one, training,
Hmm.
maybe transfer learning if you want to do it on a limited data set.
Hmm.
So training won't work, but transfer learning might work. Or the second option is using pre-trained models directly as is, like you saw this example, right? So in such
Hmm.
cases, your journey becomes easy. Generate data.
Hmm.
You don't have to worry about anything. No training, nothing. You use pre-trained models and your job is done. So according to me, I think
Hmm.
only pre-trained models is first priority choice, and second is transfer
Yeah.
learning. Other than this, you don't have
Yeah.
any other choice for edge devices.
Okay.
So that's the restrictions you end up in, as far as I know. But I
Hmm.
think developers can use several methods to tackle this: designing power efficient ML algorithms, de- developing better and more specialized hardware. Hardware is none of our business. No, they are talking about 5G network and all of it. I think from ML side you don't have much,
Okay.
right? And again, from Microsoft there is ELL. From
Hmm.
Apple, this I know. Core ML3 I know, right? Uh,
Okay.
all this help you in making those small and then deploying it in our edge devices.
Hmm. 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 Okay. Can you please copy this link to chat?
Sure, doing it right. So this is one. Now I think it's time to come back to the most important parts. Okay, so now what is that we're gonna do today? So first is your assignment, what we had. How many of you completed your text classification? Because that is the base again for today. Okay, LSTM you guys did it, but let me say. Oh no, these are the points of what we have to discuss. Out of which, okay, text LSTM was not written here, but you guys did it good. Okay, now who wants to explain this? No one? Then I'll ignore it. Even I'll not explain. It's gone. Probably we'll do it on day 4 because we already lost a lot of time today. Now, how many of you have completed this assignment? 2 and 3. Very important. I don't care about rest.
I've done.
Awesome. On which data?
I used hate speech.
Awesome. Okay. Next. Who else did on what data?
IMDb.
IMDb and what is the use case?
Uh,
Is it sentiment analysis or emotion analysis?
sorry, I was talking on mute. Akshay, can you hear me now?
Yes, I can hear you.
Sorry. The far negative and far positive neutral. Yeah.
Okay. Okay, fantastic. Anyone else?
Tried that clustering on the one of the some of the images for breast cancer. So
No, for text classification.
So that was sentiment analysis on Twitter data.
Okay, next. Nobody did product classification. Nobody. And may I know why?
What classification? Sorry.
Product categorization, catalog classification. The one which we discussed on day one, where we spoke about how it actually helps in catalog building. This one. We had these many options. The reason I'm asking is our very first topic is, before we get into the transformers, we have these many, right? We have Glove, Elmo, Talk to Vec, Sentence Bird, Universal Encoder, GPT. Yeah. And all of this implementation. So before we get into this, and I've made it easy for you guys in terms of, okay, I have these many embeddings with me. I've just created a small function wherein on your data set, whichever you want to try it out, just pass it on and then it runs. It gives you that embeddings. Right? So before we get into this, it's important that we spend some time on deep learning for NLP. Wherein so far you have run your some of the classification using TF-IDF and then machine learning based algorithms. Now, why can't I use LSTM? Why can't I use RNNs? Why can't I use simple neural networks? What is the difference? It's very, very, very important to compare and see how deep learning is changing the landscape of NLP. Right? So, like I discussed with you all, no, I think we discussed on day 2. Like I discussed with you all, for text classification, we have 3 options. You did this. Now we will do this first, and then we'll move on to this. And then we'll move on to search engines. You're getting my point? The sequence in which we're gonna go today is, deep learning. So we'll apply NLP, deep learning for NLP. Done. With this, we'll be done with this. And then we need to understand all of those BERT and transformers and all of it. And then we do this. And then now that you know all the word embeddings, all the state-of-the-art algorithms, we get into the other applications. This is how your journey looks like. So that is the reason my expectation was that you complete this assignment, which we discussed. Very, very important, because on the same data set, we would be trying out these two. Then you would know the importance, right? So it's not about just implementation. It's about you getting some experience from it. Oh, I did a product classification, and on product classification, I got, using maybe naive bias or any of these algorithm, I got maybe 80% accuracy. Then I used LSTM, I got 82. Then I used, this one, BERT along with maybe let's say naive bias, I'm getting 95. Or it can be completely other way around. You cannot just believe what I'm saying, right? If I'm saying that, oh, LSTM, bidirectional LSTM will do far better job than LSTM, and if you want to contradict that to me, I mean, you're all open, right? That's the reason I asked you to do this assignment, so that we all will know, or we all will learn together and get an experience of these three. Very, very important. If you master this, then your life becomes easier. Otherwise, let's say there's a use case, you're building a product classification or product categorization use case for one of the company. For you to try out all of this, it takes 1 month. there are 10 machine learning algorithms. And then there are 3 traditional text to features approach. So this is 3 cross 10 options. And then SOTA, we have like maybe let's say 10. And then again 10 machine learning algorithms. 10 cross 10. And how many deep learning models we have? 5. These many combinations of algorithms you need to build to arrive at the conclusion, oh, which is performing well. Do you really want to do that? No. So that's the reason you want to have some experience in terms of, oh, I ran it on product classification data set in the past, and this is how it gave me. So now I know that there's no point in trying out this because there is some context being involved in the data. Now, out of these two, I for sure know that maybe this pre-trained model doesn't work for me, some of the SOTA, because my domain is completely new. Let's say medical. So that's the reason I need to maybe use deep learning. So logically and from your experience, you arrive at shortlisting from this combination, maybe arriving at 5 possible combinations. Okay, now I'll go one by one. It's very important because I want everybody. That's the reason I did not give just one assignment here, right? I wanted to try it out and see how each of these is performing on your own data set. So hate speech, I good, like it. IMDb, I like it. Twitter, okay, we have used it. What next? Any other data set we have used? So I've got 3 data sets for today where you have done text classification. Quick. Yes, no. Nobody else has done the assignment. This is not done.
So resume screening.
You have done resume screening, but how does it fit under text classification?
Uh,
What are we trying to classify there?
the types of like matching with the job description and classifying the resumes.
It's I think you can solve that through search, right? Cause and similarity. You don't need a classification, I feel. Correct?
Yeah.
So I was trying for our own company data set on automobile.
Mm-hmm.
It's not yet complete. I had around 1 lakh records I had that I was trying, but it's kind of we have a automobile product description. I need to get the category.
Okay. So you have some automobile data, some auto data. Okay, fair enough. Next. You all will be doing today's hands-on session on your own data. Please remember that. Next. Quick. Nobody else has done it? Then I think it's better to cancel today's class. because there is no point in moving forward from here. I think maybe we can continue from next week then. Okay. Yes.
No, we'll continue.
Okay. Maybe folks who have not completed the assignment can drop off. Maybe you can listen to the recording later, because it won't add any value to the others, right? Because others will definitely be curious in terms of, hey, for me, what to make worked, but for you, why it's not working? And that's the question what Soumya and Sandeep are having in their mind when we discussed about these things. That is what they're running in their mind. Oh, on which kind of sentences, what type of algorithm would work? Why there is a need of bidirectional HTML? Why there is a need of transformer when we have word to vec? So we have all of such questions, including me. So now to get answers for all of this, we need at least 10 data sets to benchmark and say, I just got 4 for now. And I've already shared the text classification code in the last class, right? We all did it on the go in the class. So it doesn't take much time, right? Find the application, figure out the data set for that, run through it. If you really dedicate 30 minutes, your job should be done. Right? So what I'll do is maybe, I mean, let's not have any break today. So I'll give you 15 minutes. Who have not done any text classification, I want you to get your text classification in place with any data set. Maybe for people, uh, I mean, if you have trouble finding the data set, I can quickly send you some data sets. All you had to do is this. All you had to do is this. Coronavirus tweets. Go ahead and do with that. And then we have, I think you would get product categorization here only. I'm sure. Spam ham is there. Spam ham, legal, news, social dilemma, emails, IMDb, genre, movie genre, fake news, emotion, job postings, and then we have e-commerce. So I think this is your product categorization if I am not wrong. So no, not this one, not this one. This is something else. Clinical trials, another good data set to try on. News again, hate speech. iPhone reviews cancer data. I mean, fake news. So is 15 minutes sufficient for you all now that we know how to get the data set, from where to get the data set? Can we quickly do text classification in 15 minutes? Yes, or it's not possible. Again, if the data set size is huge, delete some of the rows or do head of 10K and then run it, or 20K or 50K. Is that clear?
Yes.
Yes.
Sure.
Okay. So 15 minutes. You just have 15 minutes. Let's have a new Jupyter notebook in which you do end to end text classification using maybe TF-IDF. I'll not burden you with one-hot encoding or count vectorizer. Ignore those two. Just run it on TF-IDF with maybe let's say 3 to 4 algorithms, or maybe directly use AutoML. I don't care. Which tries of which tries out all the algorithms. Yes. Let's quickly do that. And on top of the same data set, you'll be building deep learning models. And on the top of the same data set, you'll be building embeddings plus machine learning algorithms. Is that clear? So we'll understand them in parallel and then build it on your data set. I'll share the code. I'll explain and I'll share the code. Okay. So your time starts now. I've shared the link as well to the data sets. Hello everyone, is it done?
Yes, sir.
Yes, sir.
Fantastic. So can you all let me know on which all topic you did?
I did for emotion prediction from a text, sir.
Okay, what was the text? What was the data on?
Actually, it has a two columns, sir, like text, and we need to classify the either the what kind of the emotion it is, like sadness, anger, love, surprise, fear, and happy.
Yeah, I agree. But what data set that was on? Was it a social media data set or
It's
some?
Kaggle.
No, no, no,
It's a Twitter
Santosh.
data. I think I also
Oh,
Okay,
did the same thing.
okay.
okay, okay. All right. So anyone else who has done it on a different data set?
Yeah, I did it on disaster and non-disaster data sets, sir, on
Okay,
fields.
okay, good. Next. Next.
Uh, Akshay, I'm trying on the spam data set which you shared last time.
Okay. Uh, so we have Ritvik who has already done. Purnima, what about you? You just spoke, is it?
Yes, sir. I just spoke. Did it on disaster and non-disaster.
Okay, great. So I did it. Srihari, on what data set did you do? Oh, Varaprasad?
Hello.
Yes, on what data set did we do?
No, today I'm not. I'm only on mobile, so I'm not able to do anything. Sorry.
Oh, no worries, no worries. Then we have Varaprasad, Gautam.
Yes, sir. I have done on same data set disaster or not from Twitter data.
Guys, this is not exam to copy. If it was exam and if you were copying, I would agree. But this is not exam. Anyways, Gatiresan?
Sir, I did on that Twitter data.
Okay,
It's
okay, I already did. Yeah, yeah, you mentioned. Okay, what about Noor?
yes.
So legal text, citation text.
Legal. Okay, good, good. I think that's okay. Sandeep already did before. Santosh. Okay, I think we are good. So now, can you run deep learning models on the same data set? Now that you tried machine learning, can you try deep learning? Or you want my help there? I'm sure you have already built a lot of deep learning models, correct?
Yes,
So do you need my help or no?
we can try implementing, and if we need any help, we'll let you know.
Okay, so but before that, do you really have to uh, do text to features here? What are the steps you follow? Okay, you know, for machine learning models to build a text classifier using machine learning models, you know the steps and you can easily build end to end. Now, for building deep learning models, what all you need? What are the steps you need to follow?
We need to define the model,
Mm-hmm.
uh, understand using the how many the input size,
Mm-hmm.
and because that is classification into what all categories. If it is two,
Mm-hmm.
then the output layer, the dense layer.
No,
I
no,
mean,
correct. So, May, you're right. All that is, I think, understood. But my question is, okay, while you're doing using machine learning, you used to do a lot of things. Okay, first step is what you do text cleaning or processing, correct? So my question is, does that still hold good for when you're using deep learning model?
Yes.
Okay.
No,
Okay. Someone is saying no. May I know why?
I mean, feature extraction and like all that is done by the model in deep learning, so we don't have to do it separately.
Yes. I wanted this debate. Correct. Very valid point, Noor. So now everybody.
Actually,
Okay.
sir, one thing,
No, no, no. Soumya, wait. I mean, you're talking on the same topic or different topic?
same topic.
Okay, wait then. So Soumya is saying that we need to do text processing even if we are doing using deep learning model.
I
Noor
mean,
says we don't have to use. So now, how many of you are supporting Noor and how many of you are supporting Soumya? I'm supporting Noor.
Even I think we don't need to do.
Okay, even Ritvik supports Noor.
Noor, Noor.
Noor. Okay. Next.
No. Noor.
Noor. Next. Anybody who is supporting Soumya? No one?
I mean, the modeling has to be done. I mean, I support partially Noor and Soumya because both are correct in one of the ways, right?
Okay. Okay. Now, other than Sandeep, I think no one is supporting Soumya. Now I'll switch my party to Soumya. I'm supporting Soumya now. How many of you want to change your party now? Everybody with Noor still? I like Sandeep answer. Okay, now tell me one thing. Maybe for Noor supporters. I have a text wherein in first sentence I write uh, apple with a capital. In another sentence, I write apple with a in small case. Do you think deep learning models can tackle that? You all know how deep learning models work. Yes, no?
Yeah, it will capture those differently.
Which means that it cannot tackle. It will treat them differently is what you're saying somewhere, right?
Yeah, it will weigh them differently. So technically, it will treat them, but conceptually, it is one, but the ways are different. That's why it will tackle it differently.
Correct. Correct. Which means you still need text processing. That's
Correct.
wherein Sandeep was trying to explain. I'm partially agreeing to Soumya. Yes, not all processing will be taken care by deep learning models. Right? Maybe these stop words. Yeah, maybe it has tendency to extract features like Noor mentioned. But there are few logical things which deep learning models cannot tackle. So, okay, maybe I think Noor correlated this with machine learning. Sorry, in structured data. So while you're building for any structured data, if you're using a machine learning model, you do a lot of outlier treatment, missing value treatment, and all of it. But when it comes to deep learning, I don't have to do it. It takes care of itself. Right, Noor? That's your debate.
Yes, sir.
Correct? Now
Yeah.
here also it's valid. I agree. Maybe stop words or maybe some punctuations and all of it. It might take care of it. I'm not saying it will. It might. But there are a lot of such cases in text wherein processing is very important. Otherwise, it's garbage in, garbage out. It would be a blunder for models if it treats Apple with A caps and Apple with A small differently. Your outcomes will be absurd. I mean, you cannot even imagine the outcomes you would get for any model, be it text generation, text summarization, or text classification, or search engine. Okay. So now, with that note, everybody is aligned that, okay, we would need text processing in deep learning models also. Yes. Now everybody is supporting Soumya?
Yes.
Yes, sir.
Okay, good. Next. What is the next logical step we do? We convert text into features. Maybe using one-hot encoding, TF-IDF or whatever. Do we have to do that here? Yes, no. Yes, very important. Very, very important. You need to understand all of this.
Not features exactly, but a word embedding will be a better choice, like if you are
And,
building anything.
okay, so Purnima, you're right. I think it is Purnima. So you're right. But what's the point in I using word embeddings, maybe word to vec or any of this, when I'm already using deep learning model? Deep learning model does the same thing, more or less. Correct? Yes, no, no, yes. No.
Yes, sir.
Okay. So now you guys tell me, do we need text? Do we need the step of text to features conversion?
I still think it is required.
You still think it is required? Okay, why?
Uh, One thing is that even though we use deep learning, it will still understand only numbers. And by using embedding, at least we can embed context into it.
Okay. Okay, good. So everybody's aligned that do we need to do text to features?
Yes.
Okay. Now what text to features you do you use TF-IDF or do you use count vectorizer or do you use one-hot encoding?
Word embedding we'll use.
No, no, no. Okay, again, Ritvik, you're going back to the same state. So if you have seen my Excel clearly, I mentioned there are three ways to tackle. The first one is where you use this traditional text to features method and plus machine learning model. The second method is where you use SOT algorithms plus machine learning models. The third approach is where you use deep learning models.
Okay.
Now, deep learning itself is what to vec and all of this, right? Why you want to
Yes.
overfit it?
Got it.
By using TF-IDF vectorizer, like we will not be overfitting the model, but it will be a variety of words with same meaning that might help the CNN convolution neural network for better classification, text classification.
Mm, it's very simple. If I don't do text to features, do you really think your deep learning models can read your text data? No, right? It has to be numerical values or one or zeros. Correct?
Yep.
Yeah.
So which means that I have to do one-hot encoding. Correct? My next question to you all is, if at all I have to do text to features, then should I use one-hot encoding or TF-IDF or count vectorizer?
Uh, TF-IDF.
TF-IDF. Okay.
TFID.
TF-IDF. Okay. Why TF-IDF?
Because when we use TF-IDF, it also uh, like gives what is the importance of that word into the model.
Okay. And do you think deep learning models would need that?
No, they are capable of learning
Okay.
by themselves,
Okay. Correct.
but still maybe it will reduce the calculation efforts or the computational efforts.
Okay.
So
Okay.
it can run on non-tokenized data also. That will.
No, non-tokenized data, it does in the background convert it into or it encodes it, right? It one not encodes it. Yes. This is a really good discussion. See, I made blunders in my experiences, and I'm talking from that. And all of this, I'm not expecting you to know it, right? It has to come from experience. I agree. But the reason I'm asking these questions is it will make you think, and that is important. Yes. I haven't got the answer yet.
No.
Wait.
So if we're using TF-IDF for neural network, then I would say yes. I mean, the reason why I will say yes is
Mm-hmm.
purely extraction of the feature.
Mm-hmm.
I mean, you can extract it even with count vectorizer, but what we have seen is TF-IDF plays a better role in extracting the feature in deep learning models.
Okay. So how many of
And
you are
then,
still aligned with? Go ahead. So go ahead, Sandeep. Sorry.
so once we extract the feature in deep learning, then
Hmm.
we possibly reduce the dimensionality and then apply a neural network. So your computational time and or rather order and space and time complexity reduces if we do this. If we don't do it, then you will end up spending a lot of money on computation.
Valid point. Yes.
I mean, that's my thought, but I mean, people can differ if they
Yeah.
think it's not
So
right.
so so, so Sandeep, I'll tell you, right? Even I kind of was with the similar thoughts, but then once I kind of validated with the output, the problem with TF-IDF is, I agree, it extracts the important features for you, but at the same time, capturing context becomes difficult for the deep learning models. Okay,
Okay.
maybe if you
So,
are not clear, let me share my screen.
I'm just trying to think what you're saying, just trying to visualize
Yeah,
it.
yeah, correct. No. For everybody's benefit, I think Sandeep, you got it. But for everybody's benefit, let me explain this. Okay, I hate Apple. I like Apple. Ignore the spelling mistakes. I am using Mac. I like NLP. Okay, I hate Apple, but still I use Apple. Okay, so now if I do one-hot encoding, what it does, it creates the bag of words, a vocabulary, unique representation of all of these words as a column, and against each sentences it marks 1 or 0. Correct? Yes.
Yes.
TF-IDF, how it works? It does the same. It gets you the unique columns or the vocabulary, and against which instead of marking it as 1 or 0, it will mark the value against how important it is. Correct?
Yes.
Yes. Count vectorizer, let's ignore it for now. Now, think how LSTM works. If suppose for me this whole sequence is important, will one hot encoding play an important role or TF-IDF? Again, so see, I'm just digging deeper, but it's not really required, right? At the end, like you say, oh no, I'll try with all the models and then, whichever is giving me the best accuracy, I'll just use it. I'm done, right? Why the hell, I need to get it all of these details. But at some point, it becomes very important because that's how people gauge you, whether you know things conceptually or not. And by the way, if you are all still wondering, do we need text to features or not? I think it was Noor who answered it already. I just ignored it because I don't want answer to come out. So again, if I ask the same question to the previous batch, and what they told, no, text to features is not required. It's no for deep learning model. It has a capability to handle it itself. I just pass the text and it's done. Deep learning models can read the text. This is a response I got. And why they got this response, or why they gave this responses, I did a blunder of showing the code. I shared this code before in hand with them. So what they did, they went to text classification, classifying text with deep learning, and they saw, oh, some parts of text processing was done. And then, okay, we had two columns, email and target. And then we did tokenize. Okay. And then after tokenize, we directly did test and train split. And then we did label encoder. And then finally we trained the model. I don't see any one-hot encoding. I don't see any TF-IDF. I don't see count vectorizer. So the answer was no. But then what did Noor say? If you all can recollect, all we need to do is tokenize and deep learning model can handle it itself. But how does it handle? Right? It's simple encoding. What it does? It encodes it. At this layer, while you start adding your embedding layer, model.add, I'm sure I need not to explain this. Or you want me to explain this whole flow? Yes, be it for any model. You all know what each step does, right?
Yes, sir.
Yes.
Yes, correct. While you're adding your embedding, your encoding is directly taken care there. Yes. So you should know, even if from outside you're not doing anything, if algorithms are taking care of few things, you should know what it is taking care of and how it is taking care of. Right? So while in the model building process, deep learning models does encode it. Okay. So with that note, And by the way, just an announcement. Dr. Shinu, I'm not sure if you're already aware, but uh, she has a placement talk with you all from 1 to 1:30. So you have to join another call, which Harshita is gonna share sharp at 1 p.m. and mandatory to everyone. Okay, which means that we'll break for lunch after that call 1:30. Okay. So now, so here it's search engine in first place, which we'll talk about later. Okay, classifying text with deep learning. I'm using spam, which Soumya is also using. But now I'll be sharing this notebook with all of you. But I don't want you to just run this notebook. Maybe leverage some of these codes, because I don't want you to waste your time in writing your own code for building deep learning models, but run it on your data set where you have built using machine learning models, right? So all I'm doing is a bit of text processing. And once I tokenize, okay, what is this pad sequences? I'll just pick few things which I think you might not be aware or you might not have done in the past. So what is this pad sequence? And what is this maximum sequence length? Have you used pad sequences in your deep learning module?
Yes, we've used.
Yes. So what does it do?
So pad sequences is used to make all the sequences to be of the same size. Usually post padding is used by default.
Mm, mm.
And max sequence length is 300 because we want all the sequences to be of length 300.
Okay. Now, is it good? Is it a good habit to restrict? How did I arrive at 300? What was my logic to arrive at 300?
Maybe you check the length of the uh, sentence which has the highest most number of words, and then you have taken it as 300.
Uh, yes. So you do some EDA to understand the frequency or probably length of the sentences, and based on that, probably there are some sentences which are outliers, right? Which have like 2000, 3000 K words, but most of it is around 300. Then why do you want to take maximum words from bag of words? No, right? So probably you would do some EDA and get rid of some outliers and finalize your maximum sequence length. Or you take it as your bag of words length. So basically you take the length of your words in each sentence, and then based on that you directly assign it. So that is one thing. Now, pad sequences is what it does for the shorter sentences. How does it pads?
Whatever the length we have given, the maximum length,
Okay.
based on that.
Based on that, what it does? Okay, let's say I've given a 300 length,
Yeah.
and my one of the sentences is just having 100 words. What it does?
It will ensure that the sequence, all the sequence in that list will have the given length, which is max sequence length.
Correct. But what I'm saying is some of my sentences has 100. For remaining 200 space, what it does in the pad sequence? What is padding?
So zero will be padded.
Yeah. Okay. Yeah. That's all I was looking for. Fantastic. Okay. And now you do your label encoding. What is label encoding? What is label encoding?
Uh, I mean, we specify a label and then we can have value between 0 and 1.
Yes. Correct. Okay.
Basically to normalize
Yes.
labels.
Not really normalized, right? Encode. So how many classes you have, those many numbers you get.
Yeah.
As you get unique values to each of those 1, 2, 3, 4, whatever, or 0 and 1, right? And then this is your embedding dimensions again, where you can finalize. Okay, what happens is once you convert that into this embedding, right, So here there is a chance that it might explode. Do you understand what does explode mean? What does explode mean?
It will try to create more number of embeddings more where
Yes.
one cannot sustain.
Yes. So you know how it works, right? So this is how your architecture works. So now these weights, whatever you're getting, this might explode. It might go 300, 400, whatever length you have given. Now with that, your training becomes difficult. So that's the reason you need to have embedding dimension. What is the specific dimension you're looking at? Okay, for me, 100 uh, dimension is sufficient to capture the context. Okay, and then you add. Okay, can someone explain me? This is CNN, by the way. Someone explain me what each of this does. The CNN, I'll not be really keen on understanding for text because you rarely use it. Let's go to RNN, or maybe let's go to LSTM. Okay, can you tell me what are all this? I don't want model.fit explanation. Okay, what is this? Why do we need to do model is equal to sequential? What does it do in the background?
It'll add all the layers one after the other in the
Okay,
sequence.
okay. What does this do? Quick.
It adds the first layer as the embedding layer.
Correct.
Specifying.
Good. Next, what does this do? I don't need a detailed explanation. I'm just double checking if you know it. That's it.
Yeah. Next, it is
The
adding
output
the
port
LSTM layer.
harmony and then what activation function ReLU or
Hmm.
It could be the hidden layer.
Okay. So now, few important questions here. One, what is activation function? What is its role? Quick.
It
You
carries
should.
out dot product of the input and the with corresponding weight to figure out the output of for the next layer. This using this ReLU.
Hmm.
So
It
input
has
into
been
matrix.
adjusting the weights as the model keeps learning.
no,
Soumya
I mean
answered
this
it.
is activation
Hmm.
you're talking about activation ReLU, right?
Correct. Yeah, this one.
Yeah, it's an activation function in NN which will
Hmm.
output uh, the far positive or the uh, you can call it as a previse function
Hmm.
which will either output positive or if there is no positive output it will output zero.
Yes, correct. Now, I think Soumya also pretty much told the same thing in a different way. Now you tell me, this is my simple neural network. Where will I fit in my activation layer?
Before the output,
Before the output. So here is where you are
yeah.
asking me to put the activation layer. Okay.
Um,
Okay. Now, what are the other kinds of activation layer? If not ReLU, what are the others?
Sigmoid is there, NH is there.
Tanh.
TANH is
Why?
there.
What are the disadvantages of sigmoid and tanh? So that people by default try using ReLU.
sigmoid has vanishing gradient issue.
Yes. What is vanishing gradient?
In backward propagation, the weights go down. They become very negligible.
May not train the beginning of the layers of the.
Okay. So I believe all of this you already know. I need not to get into the details. But very important concept, right? How does gradients explode? What is vanishing gradient? What are the trade-offs between sigmoid, tanh, ReLU? And there are a few more as well. You can write your own negative ReLU as well, right? So now, given all of this, I'm assuming you all know it. If you don't remember, please recap or revisit your deep learning model. Very, very important from a concept standpoint. Again, I'm not looking for a technical explanation. I'm happy with the way Sandeep is explaining all the things, right? Anyone with very little knowledge should be able to understand what you're explaining with the relo or anything for that matter, right? So now, with this note, we are good with this. Now, I'm adding two activation function. Okay, what is this dropout and batch normalization here?
So dropout is to ensure that there is no overfitting.
Okay. Okay,
If
next batch normalization.
It is to avoid overfitting.
No.
It will feed data the output of LSTM in batches to
Next.
the
Okay,
next.
next. Flatten. What does this do?
It will change
It
the
will
dimension. Like
Correct. Okay, understood. So no, you were right. When I combine these two, your answer is correct, but not just these two overfitting. Okay. Next, add. I am adding another activation function here, which is softmax. Now, you guys said me that this activation comes here. Now I'm showing you another activation. Where does this activation comes?
It's an output layer.
No, it's not on the output layer.
it is for the it is the activation function in the output layer.
Not in the output layer.
it is after the output.
Not after the output. No.
Before the output.
Yes, it's before the output. Your output layer requires your responses in such a way that it it equals to your y. You're getting my point? Suppose let's say you're building a classification model and your y would be 1010, correct? Yes.
Yes.
Now, why what is the job of this output layer? All it does is whatever hidden layers throws through output, it just compares it with the actual one, calculates the error and propagate it backwards. Do the differentiation and then send it backward, correct?
Yep.
Now, how can I have it after output layer or how can I have it at the output layer?
No, not after. I mean, in the output layer.
Okay, when you say in the, it just before output. That's what you meant.
Oh, yeah.
Correct? Okay, agreed. So now, then do you think you need two activation functions before output, softmax and relu? Sandeep, I don't want you to answer. Other than you, anyone can answer. What am I doing with two activation functions and why these two activation functions are at the output? I mean, just before the output layer.
No, the first one.
No, Soumya, I'm not from you also. I'm not expecting answer from you also. Soumya and Sandeep are out. Anyone else?
Uh, these activation functions are used only for the
Noor, even you are out. I don't want Noor, Sandeep, or Soumya to answer. Next. Answer lies on the screen. Answer lies on the screen. Answer lies on the piece where I'm highlighting. Please, I'm expecting an answer. Is this really at the output layer or before the output layer? Oh man. Okay, now tell me where it comes. Okay, now tell me where it comes. I'm giving you a better diagram. or you want
Then
a more better diagram?
ReLU comes in the hidden layer.
Yes. Yes. So this is a very good example, right? This is what I was expecting. Input. See, we always talk about this hidden layer, right? But like the name says, we all want to keep it hidden. But I wanted you to double click on this. I know. So sorry. I know you all meant this here. I know you all meant here. I know when you say before output, you all meant before output. But hidden layer is not such a small thing. You're getting my point? So this activation, what you see here, is part of your LST, is part of your hidden layer. Clear? And again, even your answer is correct. It's before the output, I agree. But while you're calculating weights, this activation function is used. This activation function is used while you're throwing your output. Clear?
yes, sir.
Yes. So I would recommend all of you to go back to the basics again. Deep learning module, very important. Okay. Now, uh, again, as usual, right? You run your LSTM model. You do fit. Now, what is this batch size?
Split the training data and data into 16 size, batch of
Why?
size 16.
Why do we do that?
It's to train the models. Like we have epochs also, so that many times it will train our model.
Not bad. See, to some extent, I'm happy with your deep learning capability, but I want you to all revisit once again, recap it.
Is it to we divide into batches to ensure that we are not overfitting?
Correct. You're right. No. Yeah, you're right. So even I think so, it was Sandeep also, or maybe Ritvik trying to say the same thing. You're right. But now you're getting my point. Maybe you're answering all of this without any deep learning revision. Imagine if you could have revised, which I told when we met last time. Right? So it's an easy thing. It's not rocket science. It's very easy. It's easier than machine learning. Because if you understand neural network, you can easily explain LSTM, RNNs, or whatever, right? Okay, now again, all I do is I import some score metrics and then I run and then I print my output classification report. And now I'm running my bidirectional LSTM. I just add bidirectional here and that's about it. That's it. So here I've tried with bidirectional, I've tried with LSTMs, I've tried with simple RNNs, and then I've tried with CNN on this spam data set. Okay. So now I want you to don't worry about the first one. 6.1 will come later. Just worry about 6.2. On not you will not be running your deep learning model on this data set. Rather, I want you to run this whole end-to-end deep learning model. You can reuse this code, customize and reuse it. I'm okay. But I want you to run end-to-end deep learning models, all of this on your own data set, what you just tried building using machine learning model. Is that clear? So before we made next, I want this to be implemented. So which means that, so how much time do you need? I know there's 30 minutes, which has been took off from us. So after that, how much time do you need for lunch? Yes, tell me quick. Quick. You need 40 minutes? Is everybody okay with 40 minutes lunch today?
Yep.
Yes.
Yeah.
Okay, so 30 minutes will go in your placement session and then 40 minutes for your lunch. And then can I safely say that another 20 minutes is sufficient for us to build this using deep learning model on the same data set? And I'll be
Yes.
randomly asking 2 to 3 of you to walk us through. And what do you infer from that? What is your conclusion? Okay, you tried with machine learning, you tried with deep learning. What is your conclusion? Should I be using deep learning? Should I be using machine learning? Or is it depending? Is it really depends on case to case? What is it? So along with you walking me through, I need a conclusion also. Clear?
Sure, sir.
So let's exactly meet at 2:30. So 2 to 2:45 we'll have a presentation from one or two of you. We'll conclude deep learning text classification, and then we'll move on to things what we discussed. Word GPT. I'll as promised, I'll explain attention mechanism, autoencoders, and all of this conceptually, and then we'll move on to hands-on for all of this, along with the understanding of how they work. Yeah, that's a plan. So from 2:45, no distractions. We'll have to. There's lots we still need to finish, and then after we implement all of this, then we go back and implement all of this on text classification and see how it works. Basically, this part. Where is that? I think we discussed on day 2 or day 1. Yes, this one. It's the second one. Right now we did this. After that, we'll do this, and then we'll go back to search engine. Okay. All right then. Hope everybody is clear and we are good to go on a break.
Yes, sir.
Yes.
All right. Okay. Thank you.
Sir,
See
could you
you
please
all.
share the notebook?
Yeah, I'll share the notebook right away. Let's all meet at 2:30 sharp. Harshita, I'm sharing the notebook with you. Please share it with everybody.
Sure, sir.
All right. Okay. Thank you.